Hey, what's up you guys, my name is Harrison and welcome to School of Swag. So in this video I'll be talking about hyperbolas, which is the second video in Conics, so the second and the last video. So let's just do this. So in the previous video we learned how to identify what kind of conic it is based on the equation that you're given. So if you haven't watched that, just go and watch that first. So here we have from the flowchart, it'll tell you whether it's a hyperbola or an ellipse or something else. But once you get to realize that it's a hyperbola, then you have to differentiate between a vertical and a horizontal hyperbola. So how you differentiate it? It's this. Basically, if the y squared term is positive and the x squared term is negative, it kind of looks like an hourglass shape, like this, an hourglass shape. And if the x squared term is positive and the y squared term is negative, it looks like how I would draw an x. Sometimes I would draw an x like that. And yeah, so that's horizontal and vertical. And that's also my mnemonic for horizontal hyperbola. So if x is positive, the graph looks like how I would draw an x. So yeah, like that. Okay, so horizontal hyperbolas and vertical hyperbolas, they have slightly different equations. As you can see, you have to put you have to rearrange the equation such that one side has a 1 there and everything else kind of looks like this. So if your x squared term is positive, then you have your horizontal hyperbola. If your y squared term is positive, then you have your vertical hyperbola. So now we're going to look at a demo on Desmos.com. So I'm just gonna go over there. So this is our our vertical hyperbola. So as you can see, k is close to y, so it's y minus k. So k controls whether it goes up and down, whereas b which is also close to y. Honestly, you don't have to worry about a and b in this equation, so just focus on the k and h. So k is vertical, it goes up and down. The exact center of it goes up and down, and h, it goes from side to side. So yeah, pretty simple. These are the asymptotes. Oh, hang on. This is the vertical hyperbola, and this is the horizontal hyperbola, and these two are the asymptotes for the hyperbola, and we'll be talking about asymptotes later. So the slope of the asymptotes is always plus minus b over a. So the y part and the x part. So just follow the equation. So this b, whichever b is the part that's underneath the y, and a is the part that's underneath the x. So you just take b over a, and then you will have your slope of the asymptote. So how do you find asymptotes? So the actual equation of the asymptote, first you get the slope of it, which is just your plus minus b over a, and then you substitute that into your m, and then after that you can substitute your center point, which is here, which is the coordinate of which is h and k, which again you can already see it in the formula. There's your h and there's your k. You substitute that in, or you can just use this formula and substitute m equals the plus minus b over a, and your h and k is here, and then you can rearrange it to get your y equals mx plus c equation. So I'll just be showing you a demo again. So okay, so I guess what it's trying to say is, when I don't know, there's not much to say. It's just that this is the equation, and if you move the graph around, the equation is still there, and it just moves along with it. There's not really much to say. It's a formula. Okay, so here's what we're going to do. So if we see x plus 1 square, sorry, it's supposed to be a square, not a 2. Okay, so first thing you do, change it into standard form, and then you can graph it. And from here, you can already see that your center is at -1 and 5. So if you see x plus 1 square, it's actually minus -1. So this is something you gotta take note of. It gotta be -1. This is 5. And your asymptotes is at 2 over 4. So your, what do you call it? the gradient of the asymptote is 2 over 4, plus minus 2 over 4, and then you can substitute the center and you will get your 2 asymptotes. And that's all for hyperbola. So the summary is that the formula for parabolas is something that you have actually seen before in quadratic equations, which is why I totally skipped it. Circles and ellipses are pretty similar, except that, sorry again about this, except that these two are different, and if they're the same, you can just like multiply it up and you will get your R. For circle, you have a radius R, center H and K, center H and K. Horizontal, like radius thing, is A, vertical thing, distance is B. Yeah. And horizontal hyperbola looks like an X, sort of, right? And this is shaped like an hourglass. And you notice which is positive, and the x squared term is positive and the y squared term is positive. And your asymptotes are actually the same. And that is the end of this 2 videos on conics. Okay, so thank you guys so much for watching. Be sure to subscribe, and I'll see you guys on the next video. Bye.